Welcome to yet another class. I'm Dr. B, your chemistry teacher, and today we are going to do something very different. As a matter of fact, our YouTube channel and the Facebook channel reads Dr. B Science classes. That means that all we're going to be doing as far as our YouTube channels are concerned and that of the Facebook are concerned, or rather is concerned, it's everything that is science encompassing. So we will do mathematics, we'll do physics, we'll do biology, we'll do chemistry, all across as far as Dr. B science classes is concerned. It's not just about chemistry, but science as a whole. And today we are going to take these are classes we're going to take a different dimension, and that is looking at logarithm without tables. I know that some of you may not have idea about this part of mathematics that discusses this solving a problem in logarithm without necessarily using a mathematical table as a four-figure table or using a calculator. You do not need a calculator here. You do not also need a four-figure table. Is solving this kind of a problem in mathematics. Do not forget that in this class, Dr. B science classes, you are expected to subscribe. You are also expected to share. You have friends who are doing mathematics. Chemistry do mathematics, physics do mathematics, as well as mathematics itself. You can share this class with friends who do mathematics so they could also expand the scope of what we are doing here. Alright, so today we are going to be taking a look at how we can solve logarithm without tables. And the first question we have here is to solve log of 1 over 2, 1 over 25 base 5. I want us to know that there are laws that govern solving logarithms without tables. And one of those laws is that where you have the log of x to base a, or the log of xy to base a, which is of course a product law. So you have the log of xy to base a, that is x times y, that you should use the initial equations. Okay, we have indices, so we have the initial equations. There are laws that govern the initial equations. Those laws are the ones that govern how you can also solve problems in logarithm without tables. So now when you have log xy over a, base a, this is of course the argument, why this is the base. For in mathematics, logarithm of xy over a, xy is the argument and a is the base. That means that this is what you are arguing about, of course, to reach a solution. So in the first law of indices, this can be explained or expanded to log of x base a, okay, and then you have multiplication being changed to addition to the log of y base a. That is the first law of the logarithm, which you have to solve without using mathematical tables. So when you have products of logarithm, you have to separate the products into their individual arguments using a plus sign. So summation is likened to product, to multiplication. Now another law is that if there is a log of x over y base a, that this can also be separated to the log of x base a minus the log of y base a. That means that the arguments that you have given in a log should be separated to individual arguments to the same basis, and that separation should be carried out using a negative sign. That means that negative signs for arguments in a logarithm are a consequence of what? Of a quotient. That is a division. While positive sign in an individual argument for a logarithm is a consequence of a product, which is what? Which is times. You must understand these rules before you will be able to solve anything that we have here. Now, another law that governs it is that where you have log x raised to the power n base a, it can be rewritten as n to the log of x base a. That means that where you have an exponential that is given to an argument, that exponential should be returned to the back of the log. And that is why you have this return to the back of the log. Now, these are things that you must make sure you allow yourself to understand before you can be able to solve logarithms without tables. Now, you can go on and on and on all these laws that you have here. Okay, there are reciprocals of logarithms where you have to also consider those kind of things. Now, in the course of our trying to solve this, we'll be introducing especially these first three laws of logarithm, using them to solve the problems in logarithm without necessarily using a calculator or introducing ourselves to the four-figure table. Okay, now understanding this, which we already have here, the first three laws of logarithm, which are also likened to the initial equations in mathematics, we're going to introduce these three into solving this problem that we've been given. The first problem is for us to solve the log of 1 over 25 in parentheses base 5. And we have to solve also the log of 54 base 10, given that log of 2 base 10 is this, and the log of 3 base 10 is 0.4771. Okay, let's see how we can apply these logarithm laws that we have put down here to solving this problem. We're going to first start by solving the first problem. Okay. Now solving solution 1, which is this. Now you know that we are given the log of 1 over 25 base 5. We are given that. This should remind you of the quotient law, which is the second law of what? Of logarithm. Remember that the quotient law says where you are given the log of x over y base a, you separate them into individual arguments with the same basis using a negative sign. So if that is true, then we should have the log of x base a minus the log of y base a. We are going to do the same thing we have done here for this particular logarithm equation. So this means that, this implies that the log of 1 over 25 base 5 will be written as the log of 1 base 5 minus the log of 25 base 5. Now this is a typical introduction of the second law of logarithm into this equation. We must understand that, which is the quotient law. Now, when we have this in place, then the next thing we are going to do is to understand the fact that there is a law, and that is the fourth law of indices. That law simply says that the log of x, the log of 1 base a is 1, or rather is 0. That is what it says. It says the log of an argument which is 1 over any base at all is equals to 0, and that can be proven. But I'm not going to prove that to you right now. This is because if you said a raised to power 0 is equals to 1, because from the initial equation everything raised to power 0 is 1. Okay, so if a raised to power 0 is equals to 1, then the log of 1 base a should be 0. Quite interesting. And if the log of 1 base a is 0, then it means that the log of 1 base 5 is 0. The log of 1 to any base is 0. Okay, then it means this will be what? 0. This will be likened to this. So it means that we're going to have, we'll now have rather 0 minus the log of 25 base 5. That means that's what we're going to have. This equation now will become 0 minus the log of 25 base 5. That's what it means. But log of 25 can also be restructured. Now, for us to get this restructured, know that 25 is simply 5 times 5. Okay? This is 5 times 5. That is what this means. This 25 is 5 times 5. Then we can separate it now again into what? Into individual arguments with the same basis. So it means we can say, but the log of 25 base 5 is equals to the log of 5 5 raised to power 2 base 5. That's what it means. That's what it means. Because if we say the log of 25 is 5 times 5, that means that the log of 25 can also be written as 5 raised to power 2, which is 5 times 5. This brings us to the understanding of the other law, which was the third law of logarithm, which we had said before, that if you have an exponent, which we said, okay, I have log of x raised to power n base a, you should return the n subscript or superscript behind the log. So it's going to apply here. Now, if we have to make it apply here, that means that this our equation now will become 0 minus 2 to the log of 5 base 5. That means this 2 has been brought behind the log. The 2 has been brought behind the log. Okay, that will leave us here. But this is not all. Remember that the log of the same argument and the same base is equals to 1. Note that there is a law which says the log of a base a is 1. The log of an argument, the same argument and the same base, is equals to 1. That means that the log of 5 base 5 is equals to 1. And that's what it means. So if that is true, then it will imply that the log of 1 all over 25 base 5 will be 0 minus 2 times 1. Because we are now taking this to mean this. Okay? So it means we have here. Therefore, the log of 1 over 25 base 5 is equals to what? 0 minus what? Minus 2. And that is what? Minus 2. So it means that the answer is minus 2. It's as simple as that. We do not need to use a calculator. Neither do we need to use a 4-figure table. It's just to understand the basic laws of logarithm and then liken them to the initial equations and use them to solve your logarithm problems. Well, I'm sure that the breakdown that we have trying to solve the log of 1 over 25 base 5 was quite understandable. Okay, that will take us into solving this problem. We are given a log 2 base 10 and log 3 base 10. We are expected to solve log 54 base 10. How do we go about that? It's going to be simple. Now let us take a look at how we can be able to solve this problem. Breaking this log down to getting log 2 and getting log 3 to substitute these values. That's what you just say. You are given this log and you are given this log. This log is this, the log is this. For you to solve this, it means that you have to break this logarithm down to a point where you have log 2 and log 3 for you to now solve it. Substitute. Let's see how that works. I'm going to clean this. Okay. Let's see how this works. Okay. We are given log 54 base 10. Do you know that 2 times 27 is 54? Is it not so? Because I think 27 plus 27 should give you 54. So It means that we can have here as log 2 times 27 base 10. It's possible because 2 times 27 is 54. In this case, we have been able to do what? To get our log 2, which is given to us here. How do we get to log 3? Becomes another thing. Now, do you know also that this equation can be written as log 2 times log 3 times 3 times 3? Because 3 times 3 times 3 is 27. 3 times 3 is 9. 9 times 3 is 27. We're getting closer to getting our log 3. That means that this can also be rewritten as log 2 times log 3 raised to power 3. It is possible. That means this can also be written in that form. Base 10. And if that is true, it means that we can place it as log 2 base 10, and this is a multiplication sign, so it becomes plus log 3 base 10. Log 3 raised to power 3 base 10. We have been able to establish log 3 and 2. But this equation has it that where you have log a raised to power n base b, you can also write it as taking the n to the back of the log a and b. In that case, we'll take this to the back of the log. So it means that we'll have log 2 base 10 plus 3 log 3 base 10. We are there now. Now where we have log 2 and we have log 3, we'll substitute these values. So it implies that the log of 54 base 10 will be equals to log 2 base 10, which is 0.3010 plus 3 times log 3, which is 0.4771. All you need to do at this point is to multiply 3 by this and add it to this, and that is your answer. I don't want to be the one to solve this. You will solve it and place the answer at the comment section of our YouTube channel, Dr. B Science Classes, or on Facebook at the comment section, Dr. B Science Classes. And with this, you have been able to solve for log 54 base 10 when you are given log 2 base 10 and log 3 base 10 as these values. It's as simple as that. So you can see that to solve logarithm without tables or without calculator is quite a simple thing to do. Now in our next class, we are going to treat more examples that might seem a bit complicated to some students in logarithms without tables and without calculator. If you have any problem, drop it at the comment sections and we will attend to them. Now do not forget that you need to share this class. You also need to make comments, need to like, and when you share this class, please tell them to subscribe. The subscription is free, you are not charged. Also at the Facebook page, tell them to do what? Tell them to follow